Okay, today we are going to see the basic fundamentals of antenna in transmission lines and antenna. So, first one is introduction. Introduction, we have a first antenna was built in 1888 by the German physicist Hertz. In his prior experiment, he has proved that the existing of waves predicted by the electromagnetic theory of Maxwell's, James Clerk Maxwell's. Hertz placed a dipole antenna. So dipole means we all know that we have positive as well as negative poles for their focal point of parabolic. It can be a parabolic reflector such that one will be acting as a transmitter and another will be acting as a receiver. Antenna is intertwined with their development of radio communication technologies, and antennas are essential components in their transmission and reception for electromagnetic waves, including radio waves, microwaves, and beyond. And antenna is a device that converts electric currents into radio waves and vice versa. So these are the main part of your antenna. That is definition of antenna too. It is usually used in their radio transmitter and radio receiver. So let's see the definition of antenna clearly. So from that primarily purpose, we are going to transmit and receive electromagnetic waves that is going to be transmitted as well as received. Antennas are essential for wireless communication and they are widely used in variety of applications, including radio broadcasting, television broadcasting, cellular communication, satellite communication, and radar. There will be different types of antennas. First one will be applicable of monopole antenna. Monopole means the single pole, it has been activated as an antenna. So where work best in the narrow ranges can be collapsible. It is used in the small radios and vehicles. And second one is dipole antenna. We are going to have two poles there. One will be positive and another one will be negative. So two monopole faces always from each other, away from each other. It's used to create a powerful signal in the restricted space too. And next one is Yahoo antenna is very used in their long distance communication and for directional applications. It can reach multiple frequency at a time. It is majorly used in many areas. Then loop antenna, it works in the dipole and can be reach multiple frequencies. Commonly, it is used in TV and RFID systems. Bow-tie antenna is another type of dipole. Angles can be set to work well in the different frequencies. Dish antenna, so we can use large signals can be lot of signals can be adapted in a large surface space, and it collects a lot of signals there. It will be very working in your high frequency range, example TV and sound. Antennas are mainly has started in your World War One and Two. It is vital. It plays a vital role in their World War One and Two that is radar antennas are used to detect enemy aircrafts and ships. Communication antennas were used to touch the trips and ships on the battlefield. Antennas are widely used to develop new technologies such as microwave relay systems and electronic countermeasures. Antennas are widely used in space. Now, Chandrayaan 3 will be a best example for that. Antenna play a key role in the development of space program. High gain antennas are used to communicate with their spacecraft and to track their movements. Antennas were also used to develop new technologies such as their satellite communication and satellite television. There will be modern antenna technologies. So, what are the technologies we are going to adapt is 5G and 5G beyond 5G communication systems, satellite communication, radar systems, wireless sensor networks, IoT devices, medical devices, and automotive applications. Antennas in digital, maybe radio broadcasting, television broadcasting, cellular communication, satellite communication, GPS navigation, Internet of Things devices. Antenna of today plays a variety of applications, including radio broadcasting, television broadcasting, cellular communication, satellite communication, radar, and wireless computer networks. The emerging trend of an antenna, such as 5G and Internet of Things, plays a major role in this world. There's metamaterial antennas. Metamaterial antennas are artificial materials with engineered electromagnetic properties Metamaterial antennas are designed to have very specific radiation property and that is patterns and gain characteristics, making them ideal for a wide range of application. Reconfigurable antennas are most widely used in space as or electrical properties in response of your external stimulus, such as you can change your voltage or current. This makes them ideal for applications where the antenna needs to adapt to changing conditions, such as mobile communication systems. Smart antennas. Smart antennas can use signal processing techniques to steer their beams in their specific directions and to null out interference. So main purpose is to reduce the interference. So this makes them ideal for application where high performance and reliability are critical, such as radar system communication. Massive MIMO antennas. So massive MIMO antennas use hundreds or even thousands of antenna elements to achieve your high data rate and spectral efficiency. They are ideal for applications such as 5G and beyond 5G systems. Types of antennas. First type is dipole antenna. So majorly this antenna is used in 80s and 90s is the most wide range. So dipole antennas are the simplest and most widely used type of antenna. They are relatively easy to build and install, and they can be used for a wide variety of applications. Dipole antennas are widely used in radio broadcasting, television broadcasting, cellular communication, and wireless computer networks. The polarization of the dipole antenna can be changed by rotating the antenna in 90 degrees. Horn antenna. So there will be a waveguide and a metallic horn here. So this antenna is one of the type of antenna that is used with fluorescent waveguide to focus the radio waves into beam. Horn antennas are typically directional, meaning that it will be radiated radio waves in a specific direction only. It has an application of microwave relay systems, satellite communication, radar, then wireless computer networks, test and measurement equipment. Yahoo antenna. So this antenna is very widely used in the range of 80s and 90s in the year, and it's a directional antenna. It is one of the directional antenna consisting of two or more parallel resonant antenna elements in their end-fire array. So these antennas are most widely used for metal rods, acting as a half-wave dipoles. Yaki antenna consists of a single driven element and connected with their radio transmitter and receiver through their transmission line, and the addition of passive radiators will have no electrical connections, usually including one to be a reflector and another number we have number of directors. Major application is television broadcasting, FM broadcasting, then amateur radio, then satellite communication, radar, point-to-point wireless communication systems. Next one is dish antenna. So dish antenna is nowadays in the last decade we have used. It is known as a parabolic antenna. It's a type of antenna that uses their curved reflector to focus the radio waves into beam. Dish antennas are typically directional, meaning that it has been radiated radio waves in a specific direction. There are a lot many of application. It's used in air satellite communication, radio astronomy, radar, then wireless computer networks, test and measurement equipment. The next antenna is microstrip antenna. Now we are going to use in your mobile too. This microstrip antenna is a type of antenna that is fabricated on your PCB, that is printed circuit board. It has consist of metal path on one side of the PCB and a ground floor on the other side of the PCB. The patch and the ground plane are separated by a thin dielectric substrate, such that it will be very small in size. Micro means we all know that it's very small size. So that can be applicable in our mobile phone. Application cellular communications, wireless computer networks, satellite communication, radar, automotive applications, medical devices. Next one is slot antenna. Slot antenna is a type of antenna that is used in consists of a slots of metal surface. The slot is typically rectangular and circular in space, and it's excited by their radio transmitter. The radio transmitter from the transmitter are radiated through the slots in their surrounding space. So it is also used in radar, satellite communication, microwave relay systems, wireless computer networks, test and measurement equipment. Next one is phased array antennas. In phased array antennas is the type of antenna that is used of multiple antennas elements arranged in a specific pattern. The phase of their signal radiated from each of the element can be controlled independently, which allows the antenna to steer its beam in a different direction without physically moving to the antenna. There's many of the applications. One is radar, satellite communication, electronic counter, 5G communication systems, and self-driving cars. So 5G antennas nowadays will be a faster speed, lower latency. So 5G antenna will have 100 times faster than their 4G LET. And in their lower latent levels, there will be many applications, online gaming, real-time video streaming. So lot of applications is moving there. With having higher capacity, then 5G antennas are still developed and deployed in their major variety of live in work. And 5G networks are more widespread. We are expecting to see the innovative and groundbreaking applications that is possible in their 5G antennas.